My wonderful chemistry students. On Friday, as you know, you have the Unit 9 Learning Target 2 quiz. And there's two big parts of this learning target, and the first one is just identifying the different types of reactions, and then the other part is predicting products. So I want to make a short video walking you through this. We did it in class today, we did a full review today, but I know that this is a harder one, so I just wanted to provide a little extra guidance. If you want to follow along with me, you can. I'm starting on page 26. Okay. So identifying these different types, and this really wasn't where the struggle was. It was mostly predicting the products, but this will help us to predict our products. If we have two reactants that become one product, that would be synthesis. And here's an example of that. Here's two reactants and it made one product. So number one here is synthesis. When we predict products and I tell you that it's a synthesis, you're going to be combining these into one product. Decomposition is exactly the opposite from that. It's when I take one reactant and it breaks apart into multiple products. And number two is a representation of this, where I have one type of reactant and it breaks apart into two or more types of products. So that'd be decomposition. Now, an important thing to note here, the ones that I have listed here, these are not balanced chemical reactions. And you should note that the subscripts of the reactants do not determine the subscripts of the products. Just because there's a 2 on the oxygen here does not mean that there will be a 2 on the oxygen there. We use Brinkelhoff and the crisscross method to figure out these subscripts. More on that in just a moment. Okay, so our next one is also decomposition. And then we have combustion. So when O2 is a reactant, okay, when O2 is a reactant, and this one as well, then this is a combustion reaction. So number one is also combustion. Okay. Now, there's a special kind of combustion, and it's called a hydrocarbon combustion. This is when you have a molecule that contains only hydrogen and carbon, and it doesn't matter how much, any amount of carbon or hydrogen, but there's nothing else with it, and it reacts with O2, it combusts. Every single time a hydrocarbon combusts, your products are always carbon dioxide and water. Okay. Now, the next one here, it's tricky. It's a double replacement. So here is one of the items, and then it's over there, and we switch partners. So sodium is with this big molecule here, silver is with nitrate, and then it switches. The sodium is no longer with this big molecule, now it's with the nitrate. And then the silver is no longer with the nitrate, now it's with that bigger molecule. That is double replacement. Here's an example of this. A and B were partners, C and D were partners, and then they switched partners. So now A is with C and B is with D. That is a double replacement. All right, now another example of double replacement is 6. This one's we can see the hydroxide OH, and it's going to combine with the hydrogen. That's how we get the water. So instead of being with sodium, now it's going to be with the hydrogen, and then the sodium, instead of being with the hydroxide, is now with the chlorine. So that's our double replacement. Great. 7 is the last type that we haven't talked about, and that's single replacement. Single replacement is when we start with an item that is alone and then a partnership, and then the one that's alone kicks out someone in the partnership. So fluorine kicks out bromine. So now sodium is with fluorine instead of the bromine, and bromine's the one that's left all alone. So when you have an item that is by itself and a different item that ends by itself, that is our single replacement. And our last one here is synthesis again. So there's some questions on the quiz that we're doing Friday that look exactly like this, that I give you the equations and then you tell me what type of reaction. here's the other thing that's going to be on the quiz. So I'm turning to page 27. I'm looking at the bottom of page 27. This is actually a beautiful example. So you're going to have a couple of single replacements that you are doing. You'll have a synthesis that you're doing. You'll have a combustion. And then there's also a decomposition. So those are the ones that are going to be on the quiz. For my honors students, you're also going to be doing a double replacement. Okay? So here is single replacement. I have lithium, which is a metal, and it's the item that's by itself, and the partnership is sodium, and sodium is with hydroxide. Okay? Now, it's important to recognize and know these different items. Like sodium on our periodic table is right here, and lithium is really close to it. They are both to the left of the staircase. They're both metals, where hydroxide is a polyatomic ion, OH minus, and that's composed of nonmetals. So this lithium is going to kick out the sodium. Our new partner is going to be lithium with the hydroxide, and the sodium is now going to be all alone. Okay? I'm not worried about any subscripts over here. I'm just doing my new partners. But how do we figure out what the subscripts will be? When you have a partnership, we should use the crisscross method. And if an item is alone, then we should check with Brinkelhoff. So here's the crisscross method. Lithium is in group 1. And anything in group 1, so there's our lithium, anything in group 1 has a +1 charge when it forms an ion. Group 2 is +2, and group 13 is +3. Okay, so +1, +2, +3. Now on the other side, we have 17, which is a -1, 16 is a -2, and 15 is a -3. So any element in group 15 would be a -3. We also have our polyatomic ions that we've been working so hard to memorize. And so hydroxide, OH, is a polyatomic ion, and it has a -1 charge. So lithium is a +1, and hydroxide's a -1. I'm going to switch to a pencil for just a moment. So we have +1 and -1. Okay, wonderful. Now, when we have these charges, we would crisscross for the subscript. The one from the lithium would go to the hydroxide, and the one from the hydroxide would go to the lithium. And after we make that crisscross, then we would erase those charges. The second thing we do is when something is alone. When an item is alone, we should check with Brinkelhoff. These are the elements that when they're alone in nature, they get a subscript of 2. Sodium, Na, and sorry, my N's are kind of hard to distinguish, that's an N. So we have nitrogen, but we don't have sodium, Na. And so because it's not part of Brinkelhoff, one of these elements, I do not give it a subscript of 2. The last thing that we would do is we would balance the equation. But what's really nice is this one's already balanced, that we only need coefficients of 1 in front of all of these. There's 1 lithium on the reactant side, there's 1 lithium on the product side. There's 1 sodium on the reactant side, and there's 1 sodium on the product side. There's 1 hydroxide on the reactant side, and 1 on the product side. Okay, let's practice this again, because this really does take some practice. I have fluorine, which is alone, and then hydrogen and chlorine. Now, fluorine is really close to chlorine, okay? And hydrogen is all the way over here. So this fluorine is not going to kick out the hydrogen. It's going to kick out the item that's similar to it. It's going to kick out the chlorine. So my new partner is hydrogen and fluorine, and then chlorine is left all alone. Okay. Hydrogen, this is my partner, and so I'm going to use the crisscross method to figure out my subscripts. Hydrogen is in group 1, so it actually does make a 1+, and fluorine's a 1-. So we have a +1 and a -1, and those would crisscross to give us subscripts of 1. Chlorine is all alone, and so then I'll check with Brinkelhoff. Oh, there it is, chlorine. HCl. So it gets a subscript of 2. Now this is something I noticed as you guys were working today. Fluorine is also part of Brinkelhoff, so why is it not getting a subscript of 2? Brinkelhoff is only for items that are alone, not when they're partnered with something. So this does not get a subscript of 2. I used the crisscross to figure that out. Chlorine gets a subscript of 2 because it's alone and part of Brinkelhoff. Okay, wonderful. And then the last thing is balancing. So I have 2 chlorines here, so I need to add a coefficient, not a subscript, but a coefficient of 2 in front of the HCl. That would mean that I have 2 hydrogens, so I would have to have a coefficient of 2 there. And then this 2 applies to both the hydrogen and the fluorine, so this is 2 fluorine. Oh, and good news, we have a subscript of 2, so that would just be a coefficient of 1. All right, let's try it a third time. Silver and aluminum with chlorine. Silver is a metal, right? Fluorine was a non-metal, and it kicked out our chlorine here. Silver is a metal, and so it's not going to kick out my non-metal chlorine. It's going to kick out my metal aluminum. I'm not worried about this subscript. Okay, like I don't care that there is a 3 here. I just want a new partnership. Just like I didn't care that there was a 2 here, I used the crisscross method. So I'm going to put silver with chlorine, and the one that's left alone, all of these are single replacement, the one that's left alone is the aluminum. With my new partner, how I'm going to figure out the subscripts is my crisscross method. When in class, on the quiz I should say, when you have something that doesn't fall into one of these groups here, like +1, +2, +3, and it's not a polyatomic ion, when it's like in the D block, and we don't know what the charge is, I will tell you. So on the quiz, I'll say, hey, silver has a 1+ charge to it. Okay? So great, if this is a 1+, oh my goodness, all of these crisscross happen to be 1+ and 1-. And chlorine's 1- because it's in group 17, then this would be a 1 to 1. Aluminum's all alone, but it's not part of Brinkelhoff, so I do not give it a subscript of 2. Okay, great. So the last step is going to be balancing this equation. So right here, I have 1 aluminum, but I have 3 chlorines, so I'm going to put a coefficient of 3 here. I do not want to put a subscript of 3 because the crisscross told me that it should be a subscript of 1. Then we have 3 silver, so I would need 3 silver right there, and then 1 aluminum, 1 aluminum. Okay, wonderful. Let's go over synthesis really quick and combustion. So the subscripts of the reactants do not determine the subscript. Sorry, the subscript of the reactants, like I said, does not determine the subscripts of the products. I'm not worried about this too. I know it's synthesis, so I'm going to combine the calcium with the oxygen. I'm going to put those ones together. And because they're a partnership, they're not alone, I'm going to use the crisscross method. So calcium is a +2 because it's in group 2, and oxygen is -2 because it's in group 16. Oh, wait. If they have the same magnitude, a 2+ and a 2-, instead of doing a 2 to 2, it would reduce down to 1 to 1. So there's not any subscripts that we're going to add onto this one. This would also be true if it was like a 3 and a 3. So a 2 to 2 reduces 1 to 1. Okay, so final step is balancing this equation, and we have 2 of these oxygen atoms, so I need a coefficient of 2. The 2 applies to both the calcium and the oxygen, so I would need a 2 there. combustion is really easy, especially when it's a hydrocarbon combustion. So I have a molecule that contains only hydrogen and carbon, and it reacts with O2. It combusts. And so what we get is water and carbon dioxide every single time. Carbon dioxide and water. H2O and CO2. Okay, great. So now I'm going to go and balance this equation. So again, hydrocarbon, and it combusts always, H2O, CO2. There are 6 carbon, so I'd put a 6 here. And then there's 6 hydrogens, so I'm going to put a 3 here. And now I'm going to count up my oxygens. So I have 3 times by 1, so that would be 3 oxygens. And then I have 6 times by 2, so that would be 12. So in total, I have 15 oxygen. Oh, I ran into a problem because I can't break that in half, right? I can't put a coefficient of 7.5 here. And so instead of doing that, I need to go back to my original, and I need to add 1 to it. I need to essentially double it. So I'm going to do 2 of these molecules. Okay, great. Let's update this. Okay, so 2 times by 6. So I have 12 carbon. 2 times by 6, I got 12 hydrogens. So 6 times by 2 is my 12. So now, oxygen-wise, there's 6 here, and then 12 times by 2, so I got 24 there. So when I add those together, I have 30, and that means I'm going to put a coefficient of 15 so that I can have 30 oxygen on my reactant side as well. The one that I have not done is a decomposition. So let's quickly do one of those. I'm just going to do one right here. So a good one that we saw today was nitrogen dioxide, NO2. And I'm going to tell you, like on the quiz, I'll say, hey, decomposition. And so you know that you're going to break apart the nitrogen and the oxygen. I'm not worried about the fact that this is a subscript of 2. I'm just breaking apart the nitrogen and the oxygen. Only when items are alone, that's when I check with Brinkelhoff. But both nitrogen and oxygen are part of Brinkelhoff. So this will get a subscript of 2, and that will get a subscript of 2. And then the last thing I would do is I would balance the equation. So I'm going to need 2 of these, 2 of those, and 1 and 2. Okay, lovely. If you are in general chemistry, that's what you're going to see. So on the quiz, you're going to have to identify the different types, and then you're going to have to do this predicting products. There's going to be a couple of single replacements. There will be a synthesis, there will be a combustion, a hydrocarbon combustion, and there will be a decomposition. Now, if you are in honors chemistry, you will also have a double replacement that you're predicting. So Gen Chem, you're good. You don't have to keep watching the video. Honors, you may want to stick around while I do one last example of a double replacement. Okay. So question 5, double replacement. Copper. Now, copper is right here. Okay. And see, I don't know copper's charge, but I do know chlorine's charge, and it's a 1-. So I can figure out that copper had to have been a 2+ then, because see how this, if this was a 2+ and chlorine's a 1-, how that would result in the subscripts that we see here, that chlorine has a subscript of 2 and copper has a subscript of 1. And then these other ones, we already know those. So like sodium we know is in group 1 and it's a +1, and sulfur is in group 16, so it's a -2. And the subscripts confirm this. The sulfur has a subscript of 1 and the sodium has a subscript of 2. So how do we switch these partners? It's really important that we don't put 2 positives together and we don't put two negatives together. Excuse me, so can't put two positives together, can't put two negatives together, because they would just repel each other. We want them to combine into a product here. So this copper, instead of being with the negative chlorine, it's instead going to go with the negative sulfur. And the positive sodium, instead of being with the negative sulfur, it's going to go with the negative chlorine. Okay, wonderful. Here's our products, but we need to know what their subscripts are. And they're both partners, so I'm not worried about Brinkelhoff. I'm just doing the crisscross method. But what's interesting about this one is that we get a 2 to 2, which would reduce down to 1 to 1, and then we have a 1 plus and a 1 minus that is also 1 to 1. So I don't end up, for this example, I don't end up adding any subscripts there. All right, last step is balancing the chemical equation. So here on the reactant side, I had 2 chlorines and I had 2 sodiums. So I'm going to add a coefficient of 2 in front of my sodium chloride. I believe this is balanced, but let's check. So here's 1 Cu copper. 1 Cu copper. Here's 2 chlorines, 2 chlorines, 2 sodiums, 2 sodiums, and then 1 sulfur, 1 sulfur. Okay, so honors chem, you'll also have an additional 1 or 2 double replacement reactions that you are predicting products for. Okay, wonderful. If you have any questions, do not hesitate to reach out. Thank you all for your hard work.